Alright, the nice thing about 9.2 is the name of the section is what? Pythagorean Theorem. We already know Pythagorean Theorem?
Yes.
Yeah, because for some odd reason, when they made this book, they decided to make us use Pythagorean Theorem in the first 8 chapters, and then they decided to teach it to us in the 9th. And I can't explain that to you guys. Okay, so the nice part is we have a few days here where we're using Pythagorean Theorem and we already know. Okay? What is the Pythagorean Theorem? Thomas?
A squared plus B squared equals C squared.
Is that how they write it in the book? No, but is it the same thing? In the book they say C squared equals A squared plus B squared. Same thing, right? Exact same thing. Alright? Now, there's also some other things that we have to be careful of here. In your book, they also at some point, and let's say that you have this right triangle A, B, C. Is it also true that C squared minus B squared equals A squared? That's also true. Okay? Now, so that would be like if you were solving for A, they would do this. So if they had something like this, they would say that 13 squared minus 12 squared equal to A squared. Okay? And that works. Now, I personally don't like doing that. And the reason why is because to me this doesn't look like Pythagorean Theorem. Okay? This is Pythagorean Theorem in my eyes. Okay? Now, I'm not telling you not to do this way if you'd like to do that way. Yeah, you have a question?
I was going to say, like, if you had to solve for A, wouldn't you just plug everything in the same?
Right, so that's what I would do. I would just plug everything in exactly the same. I would plug in, if I'm solving for A, I would just have A squared plus, I'd have 12 squared equals 13 squared. Okay, it's the exact same thing, but to me, this is still the Pythagorean Theorem, so I'm not confused on it at all. Okay, now, if you want to use this, this is fine. I'm not telling you not to use this. This is how I do it. So if you are watching up here and I'm doing it this way, but you like to do this way, at least you understand why. Okay, but what is 12 squared?
144.
144 equals, what's 13 squared? 169. Okay, so A squared equals 25. Okay, that's going to be 25. Now, over here, 13 squared is?
169. Minus 144.
Don't I still get 25 equals A squared?
Yeah.
I'm going to get the same thing. Okay, matter of fact, even over here, I subtracted 144, right? So I actually have 169 minus 144. I have that same thing right here. Yeah.
Don't you have the square root?
Yeah, I'm not done yet. Okay? And then my last step to actually solve for what A is what? Square root both sides. So what does A equal?
5.
5. It'd be the same thing over here. A equals 5. Okay? Just don't get confused because they're going to write it like this sometimes. I'm never going to. Okay? It's all about how you like to do it. As long as things are in the right order, there's multiple different ways that you can solve some of these problems out. Okay, you can have Pythagorean Theorem on your theorem sheets now if you would like. Okay, I'm not going to tell you you have to because at this point I would really expect you to know the Pythagorean Theorem without having to look it up. Okay, that's something you're going to have to know. Now, something new that we do have is that definition I had you guys write down. A Pythagorean triple. A Pythagorean triple is kind of like just a special right triangle, basically. Okay? It's 3 numbers that satisfy the Pythagorean theorem, and this is going to be a different definition than what the book gives you. I'm giving this definition out of my words, so hopefully you can understand it better. Satisfies the Pythagorean theorem without any decimals fractions or radicals. A Pythagorean triple is three numbers that satisfy the Pythagorean theorem without decimals, fractions, or radicals. So if I have a triangle, first of all, is it okay to have side lengths of a triangle have decimals?
Yes.
Yeah, I might have a side length of 3.7, right? That's okay. Is it okay to have side lengths of a triangle as fractions? Sure, it might be 9 halves. Okay, it might be 9 halves for a side length, which would be 4.5. Is it okay to have radicals?
No.
Yeah, it might be 2 square roots of 7 for one side length. Okay, that's okay. But if I have any of those three things, is it a Pythagorean triple?
No.
No. Okay, this is just a special type of triangle here. We'll do some examples here in a second. Okay. Any questions on what I'm talking about by decimals, fractions, or radicals? Everybody knows what I mean by radical, right? Like a square root? Okay. Alright, if I have, and this is probably one example that you have in your notes, so I'm going to try to do a different one. Can't remember. This is going to be one. Okay, so I'll try to do one different than what you have. How do I figure out, first of all, it's a Pythagorean triple, right? Triple means what?
Positive integers and no radical.
No, what's triple mean?
Oh, 3.
3.
Oh no, so it's
Okay. Triple means 3. How many do I have?
just 2.
I have 2. What do I have to do to figure out if this is a Pythagorean triple? I got to do the Pythagorean theorem, and I got to figure out what that side length is, C. C or X, whatever you want to put in there. Okay, I got to figure out what that side length is. Okay. So McKenna, when you can set that up in the Pythagorean theorem to solve for that, I want you to write that on the board for me, please. Perfect. Everybody agree with that? Okay, a squared plus b squared equals c squared. Now, what if she were to put 4 squared plus 3 squared? Same thing, right? Same thing. Okay, you can switch these, okay? Addition is what we call commutative. It can be done in any order. Okay, so that would be okay. To solve this out, 3 squared is 9 plus
16.
16 equals c squared. 9 and 16 is
25.
25. What's c equal?
5.
5. So, Ricky, if c is 5, do those three numbers, is that triangle a Pythagorean triple?
Yes.
Yes. Is there decimals?
No.
No. Is there fractions?
No.
No. Is there radicals?
No.
No. So the answer to this, if they asked you, is it a Pythagorean triple? You would say yes, it is. Okay. Alright, let's take a look at another one here. Let's say this side length is 9, this one is 12. Okay, again, Pythagorean triple, I have to have how many sides?
3.
I have to have 3. Leah Jones, when you're ready, can you set up the Pythagorean theorem to solve for that third side for us? Everybody agree with her? Okay. Could she have said that this was A instead? Yeah, that would have been fine. Could she have done 12 squared minus 9 squared equals B squared? That would be fine also. Okay. I would set it up this way personally because it doesn't confuse me at all. 9 squared is 81 plus B squared. What's 12 squared? 144. Next step. Subtract 81. Good. B squared equals 63.
Yes.
Okay.
It's not Pythagorean.
Next step. Square root. So B equals square root of 63. Okay, now first of all, is 63 a perfect square? No. So am I going to get a whole number here? No, I'm going to have a radical, aren't I? Okay. So before we even finish this problem, can I tell whether this is a Pythagorean triple or not? Is it?
No.
No, it is not. Good. So the answer for whether it's a Pythagorean triple or not is going to be no. Okay, but you still have to go through the process and make sure that this is in simplified radical form. So what do I have to do to simplify this radical? Angel, do you remember?
You have to see what square root is.
Perfect. What perfect square goes into 63? 9 does. So I'm going to have square root of 9 on the left side. What's on the right? Square root of 7. Good job. Square root of 9 is 3 times 3, right?
It does. It's just 3.
It's just 3. Good. And we talked about that yesterday. It's just 3. Can I break down the square root of 7?
No.
No. So what is the side length B equal to?
3 square roots of 7.
3 square roots of 7. Good. Questions on that? Any questions about Pythagorean triples? Okay. They cannot have what in them?
No radicals.
No radicals, no decimals, and no fractions. Good. Okay, I got one more example here for us. I'll do a different one than what the book has here. Same idea, but a different example. Now, it does give me this also. This is the right angle. Alright. They want to know, what is the area of this triangle? And so our final goal here, I want to know area equals blank. Okay? To find the area of a triangle, what two things do I have to know? I have to know the base, and I have to know the height. Okay? Do I know the base?
Yes.
Yeah, it's 12, right? Now keep in mind, some of us had a question yesterday on our assignment. Does that 12 go with that whole side? Okay, because a lot of times they draw a line here, right?
Yeah.
And show that it's 12. How do I know that that 12 goes with that whole side, Claire? It's in the middle. Okay, it's in the middle. If it were over here, it would just go to this part. If it were over here, it would just go to this part. But it's right in the middle, so it goes to that whole side. Okay, whatever it's in the middle of is what it belongs to. Okay. Now, what am I missing? What are you laughing at? Laughing at me? That's what I thought. Yeah. Yes. Alright, we gotta know the height. Well, logically, we can guess that we're probably gonna have to use what here? Pythagorean theorem, because that's the name of the section. Now, you have to be careful here, because if this were 8, you wouldn't be able to do the process we're gonna do. Okay, so you have to be careful. These sides have to be the same to do what we're going to do here. Since these sides are the same, what do you know about these two angles?
They are
They're congruent. Why, Aaliyah?
Because of the perpendicular bisector.
Not quite. If sides are congruent, angles are congruent. What theorem says that, Thomas?
Opposite?
No.
Oh, wait, no.
I think I heard it from back there. Base angles theorem. Okay, base angles theorem says that if sides are congruent, angles are congruent. If the angles are congruent,
And the sides.
then the sides are congruent. Okay, that's base angles. Now, you guys agree if that's a right angle, this has to be a right angle? Because of supplementary angles, right? Okay. Now, if I have two pairs of angles congruent to each other, what do I know about these two triangles? They're not congruent yet. They're similar. Okay? Now, can I prove these triangles congruent? Reaching way back to our congruent triangles, Gary? I don't, not quite. Not side angle side. Aaliyah? What's that? Kind of. Other way around though. Angle, angle, side, right? So I have angle, angle, side, angle, angle, side. So are these two triangles congruent to each other? Yes. If they're congruent to each other, and this whole side is 12, what's this?
6.
This is 6. Okay, that's our goal of what we're trying to get to. Does everybody understand why that would not work if this was 8? Because we wouldn't have side angle angle or angle angle side, would we? Okay, so be careful with that. How am I going to solve for the height here? If this is 6, this is h, and this is 9. Thomas?
You need to use Pythagorean.
I'm going to use the Pythagorean theorem.
So, 6 squared plus h squared
6.
equals 9 equals, 9 squared.
Good. Hey, if you can't see that, I'll outline that real quick. Okay, we're using this triangle right here. Everybody see how we can solve for the height using that triangle? Okay, 6 squared is 36 plus h squared equals 81. H squared equals, what's 81 minus 36? 45. So h equals the square root of 45. Ricky, can you walk us through the process here of what we have to do next?
You can use 9 squared
Good, so I'm going to take out a square root of 9.
and square root of 5.
Perfect, square root of 5. So my final answer, Ricky, h equals what?
3 square roots of 5.
3 square roots of 5. Because this is a 3, this stays as a square root of 5. Good. Okay, apparently it's not going to let me do that. That's not what I want either. There we go. Okay. Now that's just my height, right? So am I done solving this yet? No, I had to go through that whole process just to figure out that this right here is 3 square roots of 5. MJ, do you remember how I find the area of a triangle? Good. Base times height divided by 2. Okay, I'm going to put 1/2 base times height because that's what the formula we actually learned says. But is that the same thing as base times height divided by 2? That's the same thing. Okay. Now, do I want to find the area of this triangle or the whole triangle? The whole thing, right? Okay. Kelsey, what is the base of my big triangle? 12, good. So when I plug this in, I have 1/2 times 12, and then what was our height, Kelsey? My height that we solved for?
Oh, 3 square root of 5.
Yep, good. 3 square roots of 5. Okay, this is something, we've done it a couple times, okay, but it's going to take a little refresher here. When I multiply something with a radical, okay, there's a couple rules we have to follow. If it's outside the radical, you can only multiply it with things outside the radical. If it's inside the radical, you can only multiply it with things inside the radical. Does that make sense? So can I combine, if I have the square root of 3 times the square root of 4, is that equal to the square root of 12? Yeah, it is. Now, if I have 3 times the square root of 4, not of the square root of equals, that doesn't make any sense. Does that equal the square root of 12? No, what does this equal?
3 square.
This equals 3 square roots of 4. Good. Okay, so just keep that in mind. Things with radicals, multiply with things with radicals. Things without, multiply with things without radicals. So, first of all, what's half of 12?
6.
6. So I have 6 times 3 square roots of 5. And what can I combine there? The 6 and the 3. So 6 times 3 is?
18.
18. Can I combine anything with the square root of 5?
No.
No. So I have 18
Square root of
square roots of 5. So the area of my triangle is 18 square roots of 5, what?
Meter.
meters.
Meters squared. Good. And make sure we have that meters squared there. Hey, you're going to have to find some area today. Now, in your directions, in your homework, it gives you this answer as a decimal. I don't want it as a decimal. I want this. And this is as exact as it can be. I want radical form, and I'll explain that when I give you guys your assignment. Any other questions on Pythagorean theorem in today's lesson? Okay, before I give you your lesson, remember if you have a test or a quiz to make up, I need you to make that up. Hey, at the end of the quarter, I will take all of these papers on my desk, I'll put them in the recycle bin, and I will enter zeros, and you won't have a chance to do that anymore. So make sure you get that done before the quarter gets over. You got 11 days. Okay, on page 538. We need to do 7 through 34. Follow the directions on every section except for 25 through 34. On 25 through 34, I want no decimals. Okay, which means you have to leave in radical notation. Questions on that? The directions say round to the nearest tenth. I don't want you to round to the nearest tenth. I want you to leave it in radical form.
If we weren't here yesterday, should we still do 1 through 6?
No, don't worry about it.
I wanted to see